So the ice table approach to solving an equilibrium problem starts off with the balance reaction. So let's start off by saying that we want to find the pH of 0.2 molar acetic acid. So this is CH3CO2H. So the balanced equation of that, we know acetic acid is a weak acid. It will partially but not completely dissociate when you put it in water. So we're going to start off with our acetic acid, add it to water, and it will come to equilibrium and form the acetate ion, so donating a proton, and HPO plus the hydronium ion. And what we do with the ice table, we have the initial concentrations, changing concentration, and the equilibrium concentration. So we know initially we have 0.2 molar. We can ignore the water. Remember, water doesn't appear in the equilibrium expression. It essentially doesn't change. And before that dissociates, we will have no acetate and no HPO plus. The changer has to go forward. You can't go to negative concentration, so we're going to lose some of the acetate, some of the acetic acid. We'll get the same number of moles of acetate formed and the same number of moles of HPO plus. So every one acetic acid that breaks down is going to give us one acetate and one HPO plus. At equilibrium, this will be 0.2 minus X, and this will just be 0 plus X, so it's X and X. Now the Ka value is going to be products of reactants, so acetate CH3CO2 minus, HPO plus concentration. These are all equilibrium concentrations over acetic acid. And we can look up a value for that, and when we do, we get a value of 1.75 times 10 to the minus 5. Remember, equilibrium doesn't have units. So let's go ahead and solve that. So we know that our acetate and our HPO plus both going to be X. And our acetic acid, if we look at our ice table, it's going to be 0.2 minus X. So this is going to be X squared over 0.2 minus X. That equals the value of Ka, which we said was 1.75 times 10 to the minus 5. That's the quadratic. What we can do in most cases, if we only need a couple of significant figures, is we can approximate by getting rid of this X. We'll say that if X is small compared to 0.2, then it doesn't have much of an effect. As a very rough rule of thumb, if you multiply the Ka value by 100 and it's less than the smallest concentration, initial concentration, you're okay to a couple of sig figs. So if we make that approximation, we know that X is going to equal 0.2 times 1.75 times 10 to the minus 5 square rooted. And that gives us a value of 3.5 times 10 to the minus 6 molar. Now that is the concentration of the acetate and also the HPO plus. You know, pH is the negative log of the HPO plus, so if you take a log of this and then change it to make it positive, we'll get the pH value. So the pH is 5.45.